Welcome to DC Digital Learning Session. I am Dr. Shobhan Kumar DM, working as Assistant Professor in the Department of Mathematics, Maharani Science College for Women. In last class, we discussed Gauss-Jacobi's method. Today, we have to discuss Gauss-Seidel method. The Gauss-Seidel method is just extension of Gauss-Jacobi's method. The Gauss-Seidel method, it gives more faster convergence than Gauss-Jacobi's method. Okay, we can use the Gauss-Seidel method to solve a system of linear equations when the system is diagonally dominant. And here, this is another numerical iterative method giving approximate solutions. This method is also applicable when the numerically large coefficients are along the leading diagonal of the coefficient matrix. That is, as in case of Gauss-Jacobi's method, here also we have to rearrange the given system of equations as diagonally dominant system. This method is modification to Gauss-Jacobi's iteration method. This method is explained as below. Consider the system of three equations in three unknowns. A given system, and we know that this is a diagonally dominant. If not, we make it as diagonally dominant and rearrange as early in Jacobi's method as it is. Whatever we discussed in Jacobi's method, now we can write here also same thing, x, y, z. Here all the diagonal entries or diagonal coefficients are numerically larger than other coefficients. Therefore, according to Gauss-Seidel method, we can write down x, y, z. Call it as equations 1, 2, 3. Now, choosing the initial approximations or initial values of x, y, z are x naught, y naught, z naught. And using in 1, 2, 3, we get x1 is equal to here y naught, z naught, y1 is equal to here. This is the main difference between Gauss-Jacobi's and Gauss-Seidel. In Gauss-Jacobi's method, when we can estimate the value of y1, we are using only initial approximation of y x naught. But in Gauss-Seidel method, we can use x1 because x1 is better approximation to x naught. Already we know that. Therefore, here we can use x1 minus c2 into z naught. And here in z1, 1 by c1 into d3 minus a3. Here already we know that first approximations of y and z. Here x and z. Here this is x. This is z p3. 1 minute. I make it as correct. Here a3x. A3x. This is x, not y. This is x, a3x, a3x, and b3y. Now z1 is equal to 1 by c1 d3 minus a3x because here x1 is known, is a better approximation to x naught, and instead of y here y1 is better approximation to y naught because we can use y1. This is the main difference between Gauss-Jacobi's and Gauss-Seidel. Okay. In case of Gauss-Jacobi's, here all we can use only initial approximations. But in Gauss-Seidel method, here we know the x1, we can use x1. Here we know the here x1 and y1, we can use x1 and y1. Okay. Now, after obtaining the values of x1, y1, z1, use these in 1, 2, 3, we get second approximation. Here x2 is equal to 1 upon a1, d1 minus b1, y1 minus c1, z1. In y2, here we can't use x1 because x2 is known. We can use x2 here minus c2 z1, and z2 is equal to 1 by c1 d3 minus here we know that x2 and y2 here minus a3 into x2 minus b3 into y2. We should carefully observe the above equations. As soon as new values of the variable are found, it is used immediately in the following equations. The above process is repeated until two consecutive iterative values of x, y, z are same. We note that Gauss-Seidel method converges in less number of iterations when compared to Gauss-Jacobi method, as we use the new value of a variable immediately in the given equations. That means Gauss-Seidel method is a faster convergence than Gauss-Jacobi's method. Now we have discussed some examples. Solve the system of equations by Here, the same equation, already we solved this system in Gauss Jacobi's method, and again we take the same problem. Here in Gauss Jacobi's method, at the 8th iterations, we get approximate values of the system. Okay, here the given system is diagonally dominant. Diagonally dominant. Therefore, according to Gauss-Seidel method, it can be written as x equal to 1 by 10 9 minus 2y minus z is 1, y is equal to 1 by 10 minus 22 minus x minus z is 2. Z is equal to 1 by 10 14 minus, this is actually not 14, this is 22, 22, 22, here 9 minus 22, 22, 1 by 10, 22, my plus 2x plus 2x plus 2x plus 2x minus 3y minus 3y minus 3y. Now it is correct. Okay, here from this equation, z is equal to 1 by 10, 22 plus 2x minus 3y. Now starting with the initial values, x naught, y naught, z naught, we take it as 0 if not given. If given, we can use the given values. Or using in the equation 1, 2, 3, using in equation 1, 2, 3, here x is equal to 9 minus 2, y naught 0, 0. We get 9 by 10, x1 is equal to 0.9. And y1, here we know that here x1, we put x1 here. Okay, here x1 is 0.9, z naught 0. We get y1 is minus 2.29. And z1 1 by 10 22 plus 2 x naught, x1 is known, we can use 0.9 minus 3 y1 is also known, minus 2.29. We get z1. These are the first iteratives or first approximation values of x, y, z. Using these in 1, 2, 3, we get the second iterations x2, y2, z2. x2 is equal to 1 by 10 into 9 minus 2 y1 minus z1, z1, z1. Here we know that y1 and z1, we get x2, and y2 is equal to 1 by 10 into minus 22 minus x2 plus z1. Here we know that here x2, put x2 value here, and z2 is equal to 1 by 10 22 plus 2x2 minus 2y2. We know that x2 and y2 put here and simplify, we get z2. Here x2 is equal to 1.0513, y2 is equal to minus 1.9984, and z2 is equal to 3.0097. These are the second iterations or approximate values of x, y, z. Now by using x2, y2, z2 in 1, 2, 3, we get third iterations x3, y3, z3. Third iterations are x3 is equal to 1.9987, y3 is equal to minus 1.9989, and z3 is equal to 2.9994. Here we go for two more iterations. Here, therefore, x3, y3, z3. By using x3, y3, z3 in 1, 2, 3, we get fourth iterations x4, y4, z4. Here x4 is 0.9998, y4 is at minus 2, and z4 is at 2.999. By using x4, y4, z4 in 1, 2, 3, we get fifth iterations x5, y5, z5. Here x5 is equal to 1, y5 is equal to minus 2, and z5 is equal to 3. The fourth and fifth iterations, this is 0.99 means is approximately 1. Here 2.99 means is approximately 3. Here these two iterative values are same up to 3 decimal places or 4 decimal places. Therefore x is equal to 1, y is equal to minus 2, z is equal to 3. These are the solutions of given system of linear equations by Gauss-Seidel method. Okay, you should remember here Gauss-Seidel is faster convergence than Gauss-Jacobi. In Gauss-Jacobi, we get the same solutions in 8 iterations, but in Gauss-Seidel, we get same solution in 5th iteration only. Next problem, solve the following system of equation by Gauss-Seidel method. X plus y plus 54 z equal to 110, 27 x plus 6y minus z is equal to 85, 6x plus 15y plus 2z is equal to 72. Here by observing this is not diagonally dominant system, therefore make it as diagonally dominant. Just rearrange the given system of equations. Here this is take it as first equation, this is the last equation, this is second equation, then it becomes diagonally dominant. Now applying Gauss-Seidel method. According to Gauss-Seidel method, x is equal to 1 by 27, 85 minus 65 plus z, call it as 1, y is equal to 1 by 15, 72 minus 6x minus 2z, this is equation 2, and z is equal to 1 by 54 is equal to 110 minus 6 minus 5, this is equation number 3. Now by choosing initial values of x, y, z, or x naught, y naught, z naught are all zeros, then we get first approximate values of x, y, z are x1, y1, z1. Here x1, y1, and z1 with initial values, we get x1 is equal to here 3.14815, y1 is equal to 3.54074, and z1 is equal to 1.91317. You should remember we are using x1 not x0 because x1 is a better approximation to x0, and we are using x1 y1 because x1 y1 are better approximation to x0 y0. Okay, by using x1 y1 z1 in 1 2 3 we get second iterations. Here second iterations are x2 is equal to 2.4321, y2 is equal to 3.5720, z2 is equal to 1.9258. Here, these are the second iterations. By using x2, y2, z2 in 1, 2, 3, we get third iterations are approximation to x, y, z. Here, x3 is equal to 2.4255, y3 is equal to 3.5730, and z3 is equal to 1.9259. Here, x3 is equal to 2.4255, y3 is equal to 3.5730, z3 is equal to 9259, 9259. Here, by observing the second iterations, second and third iterations are approximately same up to 3 decimal places. Therefore, the solutions of the given equation is x is equal to 2.425, y is equal to 3.573, and z is equal to 1.9259 can be rounded up, it becomes 6. This is the required solution. And here another problem, solve the system of equation by Gauss-Seidel method. Here in this example, we get the approximate value at fourth iterations. Here x4 is 1, y4 is 1, z4 is 1, therefore x, y, z is equal to 1. And this is another examples, go through it. And these are the exercise problem. You can solve these equations by using Gauss-Seidel method. If the given system is not diagonally dominant, make it as diagonally dominant and applying Gauss-Seidel method. These are the references. Thank you.